The following demonstration will demonstrate the achievement of Disaster Management Working Group in AIP3. This demonstration will illustrate how services in GIS can meet the requirement of producing a near real-time vehicle dispatching map based on the comprehension judgment fused by various sensor services in order to help the dispatching decision maker to make a rational decision. This scenario is completed by University of Heidelberg, Germany, Infoterra Spot Image, France, and GIS Center, Fengjia University, Taiwan. The major gap identified during AIP2 was the link between observations collected during the warning phase and the observations collected during the response phase. Frankly, even in response phase, the gap still exists. In AIP3, the scenario focuses on how to shorten the gap in response phase. To solve the above problem, a near real-time vehicle dispatching map producing mechanism will be conducted into this scenario. In this slide, there are two axes for a timeline and the version of the dispatching map, respectively. At timeline 0, the vehicle departures from the origin based on the version 0 dispatching map. At timeline T, an event takes place and observed by sensors. It changes the dispatching route of version 0. Therefore, version 1 dispatching map is produced to replace version 0. At timeline T+1, the dispatching map is changed because of another event which may affect the previous status of route. The initiator logs into GCI portal and finds the services. Integrated client subscribes and invokes these services when initiator finds out the suitable services. Actuator can query, monitor the real-time information by invoking these services. In this scenario, a WPS for shortest path calculating and a WFS for flooding area have been registered. When the typhoon warning is issued, the SOS for typhoon warning sends a notification to those service consumers by SAS. When integrated client A gets this notification, it will send a request to SOS for acquiring sensor data. Integrated client A receives and displays the typhoon warning. Actuator can see the latest typhoon warning by operating integrated client A. Meanwhile, a monitoring service is activated by integrated client A, which will activate the sensors located at the potential disaster area and begin to monitor that area. When the observations is over a specific threshold, say the accumulated precipitation meets the 200 millimeters, the data acquisition procedure will be activated again and get the real-time information to integrated client A. This is a demonstration of integrated client A. You can see the accumulated rainfall for 3 hours and 24 hours. Empty set to images. And radar echo map. Several SOS for in-situ sensors have been integrated to this client. You can see the real-time images from these in-situ sensors. When actuator needs to produce the shortest path map for vehicle dispatching, integrated client B invokes the services which are necessary for producing the shortest path map, like traffic report web service, flooding area web service. Integrated client B will deliver the request to those services and get responses. A WPS for shortest path calculation will begin to perform the algorithm and find out the optimal solution under the constraints of real-time traffic report and flooding area. The area shortest path will be delivered to integrated client B. The version 0 of dispatching map will be produced by the above steps. Dispatching operator now gets the command. He or she clicks the origin and destination in the integrated client B, then gets the shortest path. When the rainfall increased to 150 millimeters, several places are flooded and some roads in the shortest path are blocked. So the version 0 plus T1 should be produced. Now you can see the shortest path has changed. After the rainfall increased to 300 millimeters, somewhere in the shortest path in version 0 plus T1 collapsed. Version 0 plus T2 should be produced. And when the rainfall hits the red alert of 450 millimeters, most of the city are flooded. Version 0 plus T3 should be produced again in order to direct the vehicle driver to the destination by a feasible, near real-time dispatching map. In this scenario, we'd like to demonstrate the benefits of offering the near real-time information to decision maker. Due to the complexity of disaster management, the power of open standard to leverage the synergy of integrating the heterogeneous sensor services and decision model has been proved.